So now let us see what is a fuel discharge nozzle. So we have seen the fuel is coming from the flow divider to the discharge nozzle, and as fuel flows through the regulator is increased above the idle requirements, fuel pressure builds up in the nozzle lines. Now when the flow from the regulator is increased above idle requirements, the pressure of fuel in the nozzle lines will also increase. This pressure fully opens the flow divider valve and fuel distribution to the engine becomes a function of the discharge nozzles. So we have seen in our earlier slide that the fuel flow divider was supplying fuel, was responsible for fuel distribution, and from the idle range up to a certain range, the fuel flow divider was responsible for equal distribution of fuel. Above a certain range, the nozzles take the responsibility of providing equal distribution of fuel to the engine. There is one fuel discharge nozzle of air bleed type for each cylinder placed in the cylinder head. So for each cylinder there is one fuel discharge nozzle, and each discharge nozzle is of the air bleed type. So here in the figure, if you see that this is a fuel discharge nozzle, this is the place from where fuel is entering in. This is your fuel coming in from the flow divider, and then you have air also bleeding in. There is air which is bleeding in, and you can see here there is a restrictor. You can see the restrictor. We have spoken about the restrictor earlier in our earlier slides. This is the restrictor, and above a certain range, this restrictor takes care of the equal meter distribution of fuel. The nozzle is placed in the cylinder head with the nozzle outlet directed into the intake port. So the location of the nozzle is in the cylinder head, and its outlet is directed towards the intake port. Now nozzle has a calibrated jet of size dependent on the fuel inlet pressure and maximum fuel flow required by the engine. So this nozzle, this has a calibrated jet of size. Its size varies, it depends on the fuel inlet pressure and the maximum fuel flow required by a particular engine. So this is decided by the engine manufacturer, and depending on the jet size, about the calibrated jet, the fuel inlet pressure and maximum fuel flow, the nozzle, the type of nozzle is decided for the engine. The fuel from this jet enters into an ambient air pressure within the fuel nozzle assembly. So within this fuel nozzle assembly, you have an ambient air pressure, and fuel coming in enters this chamber where you have the ambient air pressure. The fuel thus mixed with air is atomized and directed to the cylinder. So this fuel coming in here and with the air coming here, the fuel is atomized and it is directed to the cylinders. So this was about the fuel discharge nozzles. We have seen in the injector system, the injector system had a fuel injector. Fuel injector in itself had a airflow section, regulator section, and a fuel metering section. From the injector, the fuel was supplied to the flow divider. The purpose of the flow divider was to distribute the fuel equally at idle speeds and above idle speeds, and from the flow divider the fuel goes to the fuel discharge nozzle. You have one discharge nozzle for each cylinder, which is located in the cylinder head and directed towards the intake port. So fuel from the flow divider comes to the fuel discharge nozzle, and from the discharge nozzle it is delivered to the engine cylinder where the fuel combustion takes place. So this was about the fuel injection system. Now Again, in the fuel injection system, we may encounter some snags, some problems. So, now let us see what are the problems faced in the fuel injection system. One problem might be a high fuel flow reading. The probable cause may be plugged nozzles if the high fuel flow reading is combined with a loss of power, roughness, or if you cannot set the idle mixture easily. So, in case if we are not able to set the idle mixture, we are experiencing power loss, we are experiencing roughness of engine operation, then the nozzles might be blocked. In that case, we may face the problem of high fuel flow. In that case, if the nozzles are blocked, then we have to remove and clean the nozzles. The procedure is given here, and once the nozzles are removed and cleaned, there is a system to check the nozzles as per the manufacturer's guidelines. Another problem might be, the probable cause of this problem might be a faulty gauge or pressure transducer. So, the pressure transducer or the gauge might be faulty. In that case also, we may encounter high fuel flow reading. If the gauge or the pressure transducer is faulty, we need to replace them, and in case of pressure transducer, it is better to use a mechanical gauge first and ensure that your transducer is operating satisfactorily or not. In case not, then we need to replace the transducer, or if the gauge is faulty, in that case the gauge has to be replaced. Another problem that might be encountered is no fuel flow indication during priming. So, once we are priming the engine and we see that there is no fuel flow indication, in that case the probable cause is that your flow divider might be sticking. Your flow divider, there is a diaphragm inside and that flow divider might be sticking. In that case, we are not supposed to repair the flow divider in the field, and it has to be sent to the repair station. Another problem is unsatisfactory fuel cutoff. Now, we have moved the mixture control from the rich condition to the idle cutoff condition, and still your fuel is not satisfactorily cutting off. In that case, the probable cause is incorrect installation of the aircraft linkage to mixture control. So, your mixture control linkage might be not correctly installed, and in that case we need to adjust the linkage, and the mixture valve might be leaking. Another reason for unsatisfactory fuel cutoff might be that the mixture valve is leaking. In that case, we need to see that if we can fix the leakage problem. In case not, then we have to replace the parts as per the manufacturer's guidelines. Engine will not increase to the necessary RPM. Now, if suppose we are giving the throttle, we are increasing the throttle and the engine RPM is not increasing according to the increase in the throttle, then what may be the reason? In that case, there may be a contamination in the air chamber. In case if there is contamination in the air chamber, we need to refer to the information letters which are given by the manufacturers. There may be small air leaks in the induction system through loose intake pipes or a damaged O-ring. So, in the induction system also the pipes might be loose, the O-rings might be damaged, from there also there may be some air leak. So, in that case we need to check the clamps, we need to check the rings, the O-rings. In case required, we need to replace them and fix the air leakage from the induction system. Apart from small air leaks, in some cases there might be large air leaks in the induction system, then it needs to be repaired. Fuel hose fitting loose. The fuel hose fittings might be loose. They may be the reason for rough idle. In that case also the fittings need to be tightened. Then another reason might be that the fuel vaporizes in the fuel lines or distributor. Now, when the fuel vaporizes in the fuel lines or the distributor, then also we may encounter rough idle operation. This is found only in high ambient temperature conditions or after a long operation at a low RPM setting. So, this is a very common problem of fuel vaporizing in the fuel lines, especially during hot conditions or during the time when we are operating engine at low power settings for a long time. So, better to keep the temperatures low and avoid long ground runs. Now, another problem might be that during taking off we have low fuel flow. So, now in case the fuel flow gauge is reading low during takeoff, what might be the reason? Again, the gauge might be faulty or the pressure transducer might be faulty. In that case, again we need to replace as required. Another reason might be that the flow divider has contamination in it. We need to clean the flow divider. Fuel pump pressure is not correctly adjusted, and in that case fuel pump pressure has to be adjusted. So, there are several reasons for low takeoff fuel flow: faulty gauge or pressure transducer, gauge or pressure transducer needs to be replaced, contamination in the flow divider, the flow divider needs to be cleaned. Again, in the field we are not supposed to clean the flow divider. It should be sent to the respective service agency. Fuel pump pressure is not correctly adjusted. In that case, your fuel pump pressure should be adjusted according to the manufacturer's recommendation. A very common problem is we are attempting to start and engine is not starting, or engine is difficult to start. Then what may be the reasons? There may be several reasons. Incorrect starting procedure. The procedure through which we are starting might be incorrect. Flooded engine. The engine is flooded. That means more than the required fuel has come to the engine. Throttle valve is opened too far. So, throttle valve is too much opened. In that case, your engine is difficult to start. A prime that is not sufficient. So, your priming is not sufficient. So, several reasons you have seen why engine is difficult to start. In case your starting procedure is incorrect, then we need to refer to the pilot's operating handbook, to the manufacturer's recommendation to correct our procedure, starting procedure, and start the engine as per the manufacturer's recommendation. Another reason might be flooded engine. Your engine has been supplied with more than the required fuel. In that case, crank the engine to clear it with the throttle open and a mixture in the idle cutoff position. So, flooded engine needs to be cleared. It is cleared by cranking the engine with the throttle open and a mixture control in the idle cutoff position. In case if the throttle valve is opened too far, then also you will experience difficulty in starting the engine. In that case, the throttle should be opened so that you have approximately 800 RPM, and it should be opened, the throttle should be kept in the open condition as per the manufacturer's recommendation. In case the priming is not sufficient, then priming has to be increased, the quantity of priming has to be increased. Another problem, engine operates rough. Now, when you have rough engine operation, what might be the reason? Too rich or too lean mixture. Now, when you have either the mixture is too rich or too lean, then also you will have rough engine operation. Another reason might be the nozzles are plugged, nozzles are blocked. Another reason, air leak in the induction system, leakage in the induction system, that is the reason. Air leak in the fuel line with the fuel from the fuel tank to the servo. So, there is a air leak in the fuel line also. Flow divider sticks and the flow divider is sticking. So, several reasons you have seen for rough engine operation: too rich or too lean mixture, plugged nozzles, leak in the induction system, air leak in the fuel lines and flow divider sticking. So, let us see one by one. In case if the mixture is too rich or too lean, we need to adjust the mixture control as per the manufacturer's guidelines. The procedure is given and we will discuss also about the mixture adjustment. In case if the mixture is too rich, we need to lean it slightly. If it is too lean, then also we need to rich it slightly. Now, in case if the nozzles are plugged, nozzles are blocked, then we need to remove the nozzles, clean the nozzles, and there is a procedure how to clean the nozzles, and after cleaning we need to check the nozzles as per the manufacturer's guidelines. Once the nozzles are okay, we need to install them back. If there is a leakage in the induction system, there is a air leak in the induction system, then also your engine will operate rough. In that case, we need to check for the leaks and fix the leaks accordingly. In case if there is an air leak in the fuel line, we need to check for the leak and there is a procedure given how to check. We will check for the leaks as per the manufacturer's guidelines. Flow divider sticks, in that case we need to inspect the flow divider and inspect the flow divider installation for looseness, for any physical breakage. In case not, we need to replace the flow divider, because we are not supposed to do any maintenance in field on the flow divider. So, it is better to send the flow divider to the servicing agency and replace it with a new flow divider. So, these were the several reasons why the engine was operating rough: too rich or too lean mixture, plugged nozzles, leak in the induction system, leak in the fuel line, flow divider sticking, flow divider faulty. So, we need to take rectification actions accordingly as per the manufacturer's guidelines. So, these were some of the problems encountered in the engine injector system, and now let us see what are the maintenance and field adjustments we carry out on the fuel injector. This fuel injector inlet strainer, you see here in the figure, this is your inlet through which the fuel is coming inside the injector, and inside this you have a strainer, you have a filter which will filter the fuel. So, there has to be some inspection on the filter. The fuel injector inlet strainer should be initially removed and cleaned at first 25 hours of operation. So, at first 25 hours of operation, we will remove it and clean it, inspect it, and after first 25 hours of operation, at every 50 hours of operation, we need to remove the fuel inlet strainer and clean it, inspect it and install it back as per the manufacturer's recommendations. Another maintenance and field adjustments on the fuel injector is generally limited to idle speed and idle mixture adjustment. So, basically on the injector, apart from doing visual inspections, checking the unit for satisfactory installation, for any loose connections, we can only do idle speed and idle mixture adjustments. Let us see what are the steps when we do these adjustments. The general steps are: carry out magneto check during engine ground run and observe RPM drop for each magneto. So, before attempting to do any adjustment on the injector, we need to do a proper engine ground run up. During the engine ground run up, we will check the magnetos. We will study about the magnetos in our next lecture, and we will check the magnetos. We will do an ignition check and check the drop in the magnetos. If everything is satisfactory, then only we will proceed for idle mixture adjustment. Now, with the throttle placed at idle position, observe idle speed is in the recommended range. Now, during the ground run, we have put the throttle in the idle position, and let us see the idle speed. If it is in the recommended range, fine. If it is not, then we will adjust the idle RPM with the idle speed adjusting screw. Here in the figure, you can see this is your idle speed adjustment screw. Through this screw, we will adjust the idle speed and see if it is in the satisfactory range. Now, with engine RPM in the satisfactory idle range, we have adjusted the idle RPM, engine idling satisfactorily. Gradually move the mixture control lever towards the idle cutoff position. Now, with your engine idling properly, we will gradually move the mixture control from the full rich position to the idle cutoff position and observe the tachometer for RPM variation as the mixture control lever is moved towards the idle cutoff position. So, as the mixture control lever is moved from the rich condition towards the idle cutoff condition, we will observe the variation in the engine RPM. An immediate increase in engine RPM indicates that the mixture is on the rich side of the best power. So, as we are moving the mixture control lever from the rich condition towards the idle cutoff condition, and your RPM immediately increases, that indicates that your mixture is on the richer side. An immediate decrease in RPM indicates that the mixture is on the leaner side. The proper thing, the indication that your mixture is set properly, the mixture is okay. This mixture is rich enough to provide satisfactory acceleration under all conditions and lean enough to prevent spark plug fouling or rough engine operation. So, during the movement of mixture control lever from rich position to idle cutoff position, if the RPM increases from 25 to 50 and then drops, this indicates that your mixture is correctly set, and this mixture gives you satisfactory acceleration under all conditions and is also lean enough to prevent spark plug fouling or rough engine operation. In case if idle mixture adjustment is required, then turn the idle mixture adjustment screw in the direction required for correction. So, this is your idle mixture adjustment. In the figure you can see here, this is a wheel through which you can adjust the idle mixture adjustment. So, in case if the idle mixture adjustment is required, then turn the idle mixture adjustment screw in the direction required for correction and recheck as mentioned above. Check and adjust until the mixture is satisfactory. Between the adjustments, clear the engine by running it up to 2000 RPM before making the mixture check. So, in between the adjustments, we also need to continuously clear the engine by moving the throttle to 2000 RPM and then moving it back. Once the mixture has been adjusted and mixture is set, we again check the idle speed, and in case if any adjustment is required, we will adjust it accordingly. If the setting does not remain stable, check the idle linkage for looseness. In case after doing all this thing we are facing any problem, then we also need to see whether your linkages and everything is not loose and everything is properly attached. The idle mixture and RPM checks should be carried out with the airplane placed in the crosswind. So, we need to take some precautions while we are doing these adjustments in the field. The aircraft should be placed in the crosswind because the wind blowing can affect your engine RPM, and we should also take into account the prevailing weather conditions while doing these adjustments. So, this was about the fuel injector, the fuel injection system, the problems being faced in the injection system and some of the maintenance steps and adjustments that are required on the injection system. Thank you.